Hello, welcome to Pre-Cal Lecture 3.3, where we go over some really common functions that I would like you to be able to recognize when you see the graph. So the first one, we'll call this 3.3.1, is our constant functions. So you'll be doing this on your own paper. You're going to be drawing a lot of graphs today. All right, so let's say we have this situation. So the x-axis, the y-axis. We've got the origin here at 0, 0. I'm going to draw. So a constant function, I'll draw the actual lines in a different color, would be f of x is equal to some constant c. Okay, so f of x is just a fancy way of saying y. But this is function notation, and it's very, very useful in math. So we're going to start moving away from y and moving towards using f of x. So let's say we have, let's have some table of values here. So f and f of x. Remember, f of x is just y. Okay, let's say we have -1. Well, with a constant function, the y value is just going to be some constant c. No matter what x is, the y value will be the same. Okay, so if we have a point C on the y-axis, it could be 5, 2, whatever, then the graph of this function is just going to be a horizontal line. All right, so that's f of x equals c. Okay, for our next common function, it's going to be f of x equals x. So if we want to have a table of values for this, no matter what x is, the y value, which we're calling f of x, is going to be the same. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. Okay, so draw this graph out. My vertical line is not particularly vertical there, but you can do better. Okay, so what this function looks like is really, it just bisects the first and third quadrant at a 45-degree angle. So this is f of x equals x. All right. Well, let's keep going. And I want you to be able, when you see these types of functions in our dealings, you kind of know what the graph looks like. Or if you see what the graph is, you know basically what the function is. Okay, let's do 3.3.3. And that is going to be f of x is equal to x squared. Now you might remember from your algebra classes that this is a parabola. So if we're going to plot or put a table of values, if x is -1, f of x is -1 squared, right? So that's 1. If x is 0, f of x is 0, 1, 1. If x is 2, we square that, and f of x would be 4. Okay, so let's remind you what a parabola looks like if you've forgotten that. Okay, beautiful graph. Of course, it can be skinnier or wider, but that's its basic shape. F of x equals x squared. All right. Now this is called a happy face parabola. So if the constant in front of x squared is positive, everything goes up. But there's another kind of parabola that I'll draw. We won't do a number plot here or a chart. Just draw it here. So we can have a sad face parabola that goes down like that, and that is f of x equals minus x squared. So if there's a minus any coefficient, a negative in front of the x squared, the parabola is going to be pointing downward. All right. So there you go. So we've got 3 common shapes. We've got we're going to do a total of 8, I believe. Okay, 3.3.4 is f of x equals x cubed. All right, let's make a little table. So if x is negative 2, negative 2 times negative 2 times negative 2, cube negative 2, that's negative 8. Negative 1 would be negative 1. 0 cubed is 0. 1 cubed is 1. And then 2 cubed is 8. So this particular function, the values can go negative. All right, so it's going to look something like, and of course, if we have a different coefficient in front of x cubed, that changes the width. It can change. It can, if you add a number, it'll keep it. It won't go through the origin. You know, there's a lot of ways to change the graph, but we're just looking at the basic shape here. So that's our cubic function. All right, let's keep going. I've got room for another one on the board here. Call this 3.3.5. And this is the square root function. All right, let's make a table of values. F of x, remember, f of x is just y. All right, let's say we have negative 1. Well, if you take, so this is f of x is equal to the square root of x. If you take the square root of negative 1, that's undefined. All right, now I know we have complex numbers, but complex numbers are just a tool to deal with undefined. It's helpful in certain branches of science to be able to take the square root of a negative, but we are not going to be graphing it here. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. Okay, so let's draw the basic shape of the square root function. And so see, it doesn't go to the negative side of the graph, and it increases at a decreasing rate. Okay, so if you see something like that, it's some kind of square root function. All right, look at us go. All right, 3.3.6, we'll call this the absolute value function. All right, so this would be f of x is equal to the absolute value of x. So we've dealt with absolute value in chapter 1. It makes any number negative when you take the absolute value of it. It is positive. Okay, so if x is negative 2, f of x would be 2. If x is negative 1, f of x is 1. 0, 0, 1, 1, 2, 2. So what does this graph look like? Well, it kind of looks like f of x equals x, except you have that on both sides. So it's really kind of like a big V like that. So this is f of x equals the absolute value of x. All right, and then finally we have the, tell you what, I'm gonna want more space for this one, so I'm gonna go ahead and erase. So the last common function that we're gonna talk about is the greatest integer function. Now, I don't know if you've talked about this one in your algebra classes or not, but that is f of x, and you get this interesting looking symbol, kind of is like a bracket, but it's got some extra lines on that bracket. But the greatest integer of x, so the greatest integer is the biggest integer, and so no decimal, just a whole number, that is less than or equal to x. Okay, so let's go ahead and do a table of values here. So let's say x is negative 1.7. You always round down to the next integer. You're rounding down. So the greatest integer function, the f of x, will either be equal or less. So the next integer downward is negative 2. Let's say you have negative 0.3 for x. The next integer rounding down, you don't round to 0, that's rounding up. You round down to negative 1. How about if you had 0.6? That would round down to 0. 1.9, that wouldn't round up to 2 with the greatest integer, it rounds down to 1. 5.3 would round down to 5. So what does this thing look like? Well, it's not easy for a poor artist like me to draw, but I will give it a go. So I'm going to go ahead and mark some lines here. 1, 2, 3, 4, 5, -1, -2, -3, -4. We'll do that. And I'm going to go ahead and mark some y values. 1, 2, 3, -1, -2, say -3. Okay, so what you have, for any number less than 1, it rounds to 0. But you don't include 1. So if x is 2, it would round down to 1. Okay, except if it's 2. If it's 2, it rounds to 2. If x is 3, it rounds down to 2. If x is 4, rounds down to 3. All right, and we would have the same thing to the left. If x is 0 or less, it rounds down to -1. If x is -1, less than -1, it rounds down to -2. So this is called, so we have, this is, we'll call this f of x is equal to greatest integer of x. And usually on the board I would just do brackets. In the textbooks it'll have an extra line there. This is called a step function. All right. So as long as you can do this part, you're not really going to have to draw it. As long as you can do this part, and we're going to do some examples now on greatest integer, but as long as you can calculate the greatest integer, you're good. So let's do some examples. So our first one is, what is the value of, and we've got the brackets around it, 10.412. Okay, so what is that? Well, with the greatest integer, 10.412 rounds down to 10, to the next integer downward. All right, let's do another one. All right, what is the value of, how about, and this is where students mess up, -2.805. They might accidentally go the wrong way, but the answer is this rounds down to -3. And then finally, we want to evaluate greatest integer 4.6 plus greatest integer 5.6 minus greatest integer 4.6 plus 5.6. Okay, so you just do them one at a time. So this would round down 4.6 to 4. this would round down to 5. But 4.6 plus 5.6 would be, what, 10.2, right? So that's 10.2. So that would round down, because we have to work inside out. Let's do that first. Round down to 10. So 4 plus 5 is 9 minus 10. That is -1. Okay, so there's no... I wanted to break this up into 2 videos. I'm going to do a video on section 3.4, and then the worksheet comes from 3.3 and 3.4. So the next lecture goes with this lecture. So we won't talk about the homework worksheet yet. All right? And so that does it for lecture 3.3. I'll talk to you on the next one.